Hi friends, welcome to Learn Max Easily channel. Now we are going to see about class 10 Max chapter 2 polynomials. So okay, which or what is polynomial we saw in class 9. So now polynomial is being represented by p of x, and in p of x the highest power of the x value will be the degree of the polynomial. So that's been given in your first introduction. So 4x minus 2. Here the highest degree is 1. So the degree of the polynomial is 1. So like these are the basic things that we have to know while we are moving into this lesson. This 5x cube minus 4x square plus x. So here the highest degree old value is 3. So the degree of the polynomial here is 3. Okay. Now when the degree of the polynomial is 1, when the degree of the polynomial is 1, it is called what? Linear polynomial. Linear polynomial. Say for example 4x minus 3. So over here the highest degree, as I told you, for calculating degree of polynomial we have to see the highest degree that is been present in the entire polynomial. So here the degree of polynomial for this, that is the linear polynomial, will be 1 always. Okay, the degree of polynomial for, that is the degree of a linear polynomial is 1, or when a polynomial has a degree of 1 it is called as linear polynomial. Okay, yes. Now the same way when the degree oh, when the degree of the polynomial is changes to 2, it is called quadratic polynomial. Quadratic polynomial. When the degree, the highest degree in the entire equation is 2, then it is called quadratic polynomial. Say for example here they have given the highest, that is the quadratic polynomial examples are 2x square plus 3x minus 2 by 5. Here the highest degree value is 2, that is x square. The 2 value is the highest degree in the entire equation, so that becomes the quadratic polynomial. So again cubic polynomial, the next one. Okay, the third one which we see here is cubic polynomial. Cubic polynomial. Again for cubic polynomial, as we saw here, the thing which we, that is 5x cube minus 4x square plus x, that is one of the example which we saw at the beginning, that holds good for a cubic polynomial. Okay, the degree, the highest degree is 3 over here, so that comes under cubic polynomial. The degree of the polynomial, the highest degree is 3, so that holds for cubic polynomial. Okay, so these facts are being studied in our lower classes too. Now further we move on to this chapter. Now what the we know that for a quadratic polynomial the general equation will be ax square plus bx plus c, right? So c holds for constant and ax square bx with some that is x square with a coefficient and x with b coefficient, and the highest degree holds here is 2. So now for a cubic polynomial the same thing, but the degree value changes, that is ax cube plus bx square plus cx plus d, right? So the over here the highest degree value is 3, so it is a cubic polynomial, where a b c d are real numbers. So when where the value, that is the cubic or quadratic, the total or over here the value increases by the following next polynomials, right? Okay, these are some of the very basic things which we have to know while entering into this lesson. Okay, now they have given one example over here. I point out it over here. It is p of x equal to x square minus 3x minus 4. By this equation, next what they have given is x is equal to minus 1. They are asking what is the value at x equal to minus 1. This is generally mere substituting the value of x at the entire equation. We get minus 1 the whole square to be 1 minus 3 into minus 1 is minus 3, and a minus is present over here, so it becomes plus 3, and this minus 4 remains the same. The entire value will be 0. So at p of minus 1 we have to represent the thing like this. At p of minus 1 the value of the polynomial is 0. Okay, then they are substituted for 4 also. So for 4 again we arrive the same value 0. So again we have to represent as p of 4 for this polynomial. P of 4 is equal to 0. Okay, the 4 that this 4 holds that it is been substituted in this equation and the result arrived is 0. So we are writing p of 4 is equal to 0 below this equation. This equation is represented as p of x. This this x value is being replaced with 4, and the value of the entire equation is calculated and arrived as to be 0. So what why we are seeing this? Okay, we are substituting here to be 4, we arrive 0. Okay, everything is fine. Why we need to check, why we need to do that? It is nothing but for that particular equation 4 is the zeros of the polynomial. For that particular polynomial 4 is the 0. So for a polynomial, when a number is being substituted to it and it yields 0 as its result, then that will be the zeros of the particular polynomial. For x square minus 3x minus 4, what we got, we are substituting 4, we got 16 minus 16, we arrived 0. So for this equation 4 is the 0, right? For this equation or this polynomial 4 is the 0. So zeros of the polynomial for this equation is 4. Another way, see, we can find the zeros of the polynomial by this way. Another method to find the zeros is for an equation that is being given ax plus b, ax plus b, say for example 2x plus 3. For this equation we have the formula minus b by a for finding out the zeros. So it holds to be minus 3 by 2. So for this equation 2x plus 3, the zeros is minus 3 by 2. Okay, what is the zero? So what we have to, how we can check whether the answer is right or not? So just merely substituting this minus 3 by 2 in the equation 2x plus 3, that is 2 into minus 3 by 2 plus 3, what we arrive is 0. So minus 3 by 2 is the 0 of this polynomial 2x plus 3. Fine. So this equation again, as we saw, x square minus 3x plus 4. So for this equation, this is not a linear equation, this is a quadratic equation. So for this equation, how we can arrive the zeros? We can, splitting up middle term method we can use for arriving the zeros of this equation. What will come if we do splitting up the middle term equation and finding x value? We arrive, yes, 4 and 1, x square minus 4, sorry, plus 4x. Now this cannot come in splitting up the middle term, because we cannot get the multiplication number. So we can do it with a quadratic equation formula, minus b plus or minus root of b square minus 4ac by 2a, right? So why I took that one is to generally understand what is the concept of that minus b by a and telling the zeros of the polynomial. Zeros of the polynomial is nothing but a number which is substituted in the polynomial the entire polynomial, it yields 0 as result. That is the zeros of the polynomial, numbers which yield the 0 as a result when substituted to that polynomial is the zeros of its polynomial, right? Yes. Now before, over here they are just giving or explaining about the graphs to determine the zeros of the polynomial that has been given, right? See this, consider this case 3 example. This is the graph that is being represented. This is the graph being represented. Now over here there is no 0 because this curve, just watch carefully, these curves do not touch the x-axis, is not touching, right? So there is no zeros in this case. So this will be analyzed in the exercise that is being given. There is nothing much to be seen over here. Look at this exercise. The first question, what it deals actually, see, y equal to, the graphs of y equal to p of x is given below for some polynomials p of x. Now what is the number of zeros of p of x in each cases? Okay, they are asking us to find the number of zeros. See, just read the question, number of zeros of p of x. So p of x, they are particularly specifying p of x over there, p of x. So the curve that is been touching the x-axis line, see a number of times over here, 1 2 3, so 3 will be the zeros. So if it there is not touching the x-axis like this, then there will be 0 because they are asking for p of x. So when they are asking like this, we have to consider this one, that is y equal to p of x. They are specifically given in the first line of the equation. That is the question, y equal to p of x. Over here, what we have to be careful with our side is we need to check the number of touching points in the x-axis of the given question, and that will be the zeros of p of x over here, right? So for the first question, see the first question that is being given here, this one. Yes, how many times the line is touching x-axis? 0. So what will be the number of zeros in p of x in each case? That is the first case. The number of zeros is 0, simply 0. That's it, because it is not cutting any point in the x-axis. As I told you here, this is a general depiction. Have this as a general depiction. Okay, it is not touching, right? This is x-axis. It is not touching, the line is not touching in x-axis. So the number of zeros of this polynomial of, or for this case, it is 0, right? So for second, that is this one. Okay, for this one, what we have to see, the number of times it is touching the x-axis. See over here, yes, only one time. So the answer over here will be 1. This one is not touching, x-axis, is touching y-axis. So for this it is 1. For third one, now in third one, you just see at x-axis how many points are being touching. See clearly, there are up to 3 points that has been touching in the x-axis. Wait, just watch it clearly, because consecutively 2 points are touching it, so we may miss out that point, and we calculate it to be 2 only. Over here 1, over here 2, right? The curve, wait, the curve comes like this, it goes and it comes like this. See, the x-axis is present here. This is 1, this is 2, this is 3. You actually, while solving this problem, most of the guys will take these two as 1, and final answer they will arrive as 2. So that is literally wrong, because that point is, this curve is very at a minimal stage. So but this point is to be considered, and the number of zeros present over here is 3, right? The fourth one, wait, yes, what is the fourth one given? Again, the fourth one, it is just like this over here, so it is 2. So fourth one, 2. For fifth one, see again, you have to see, when a curve is a complex like this or like this, something like that, we have to clearly see that how much times it is literally touching the x-axis. So for fifth one, 1, 2, 3, 4. 4 times it is touching the x-axis line. For sixth one, 1, 2, 3. Why? Because see, it is like this, 1, over here 1, my touch, so 2, 3. It is touched and gone up. So there is a touch. There is not like, it is not like this. There is not a gap. There is no gap. It has been touched and went upwards. Whatever it goes, wherever it goes, no problem. Whether it may go like this or it may go like this, but it it touched the x-axis surface, so that will be counted as a 0. At a point it came to 0 and it went, so it is calculated. So the net answer for the sixth question is 3, right? So just these 6 subdivisions are there in this equation. We need to see how much times the line touches the x-axis. That will be the zeros of the polynomial given. That's it, no more things to be analyzed or understand in this part, okay, in this exercise, right? Now, before getting into second exercise, again we need to see certain topics in between first exercise and second exercise so as to work out the second exercise problems. So again, now they are talking about zeros but in a different way. There are two types, that is they will generally term it as SOZ and POZ. What does it mean actually? SOZ is nothing but sum of zeros and POZ is nothing but product of zeros, right? SOZ, sum of zeros. See, for a polynomial, let's we assume A and B are its zeros for a polynomial. So the sum of zeros is nothing but A plus B. This product of zeros is nothing but AB, right? This is a general definition or something like literally assuming or representing the sum of zeros and product of zeros with respect to the zeros of a particular polynomial. So with this, what we are going to do, what is the use or what can be analyzed by this is the main content of this particular part in this lesson, right? Generally a polynomial, it is represented as ax square plus bx plus c. For this sum of zeros, there is a formula to find it is nothing but minus b by a. Minus b by a. B is this one, a is this one, minus is again present in the formula itself. So minus b by a is the sum of zeros of this particular polynomial ax square plus bx plus c. Whatever the polynomial it may be with numbers, that is for example 2x square plus 3x plus 3. Again at B position it is 3 and A position it is 2. So sum of zeros will be minus 3 by 2. So it is for everything. For general representing, they are given as minus b by a for ax square plus bx plus c. So it is for calculating sum of zeros. Now, product of zeros for the same general polynomial. This is a general equation of a polynomial. So for same thing, what will be the product of zeros? It is, the formula is c by a. The formula for finding product of zeros is c by a, right? So here what we have to have in mind, what the mistake which we guys perform at that age is nothing but the first thing is in sum of zeros we have to put minus, that should be in our mind, and for product of zeros it is plus, right? The common term for both is divided by a. That will not change, that should not be changed by mistake. If you put divided by b or something else, the entire answer is wrong, right? Then the sum of zeros has minus in it, product of zeros has plus in it, and for sum of zeros it is b with minus symbol, product of zeros is c with plus symbol. That's it to be remembered. If it is interchanged, this two here and this two here, the entire sum goes wrong and they won't even give you a single mark to that question, right? Not only writing the sum of zeros as minus b by a and say for example x square minus 3x plus 2. See, this is one of the example. Let's we take this polynomial to be the example to find sum of zeros and product of zeros. So over here sum of zeros is, as we guys with the formula, it is 3. Product of zeros is 2, right? So just merely finding this, the in board exam or in your school exam they'll just give this one, that's it. To you just find the sum of zeros and write the product of zeros, that's it. Not they won't give you like this, they won't be even a sum, okay? What they will ask you guys to do is they will provide this one. The sum of zeros and product of zeros will be provided by the question. They will ask you to find what is the equation, They will give you sum of zeros, they will give you product of zeros, but they will ask you to find what is the equation that is being that holds good for this sum of 0 to be 3 and product of 0 to be 2. So in this case, again, the sum or the method which I told will be reversed, but that too we have to know a certain what to say, a trick or a certain concept to apply this one in the equation to obtain the polynomial. What is that? We'll just erase this. Okay, entirely. I'll tell you again, don't worry. Sum of zeros is 3. Let's product of zeros to be 2. Okay, so this over here, I think we studied this in younger classes. Okay, it's nothing but x square minus sum of zeros 3x plus product of zeros 2. That's it. Okay, generally the quadratic equation will be like this. So it again a polynomial x square minus sum of zeros of x plus product of zeros. So by this we get this one, x square minus sum of zeros is 3, so minus 3 plus product of 0, the product of 0 is 2 plus 2. That's it, right? Okay, these are general things. Actually this lesson fully deals with the general polynomial things. Nothing much to worry about that. The sum of zeros is generally represented as alpha plus beta, and before that alpha and beta are the zeros of any polynomial. Okay, we can consider or you assume whatever it may be, but alpha and beta are zeros of the polynomial. Okay, so sum of zeros of a polynomial is generally represented as alpha plus beta, that is equal to minus b by a, as I told you. Then product of zeros is equal to alpha beta, again that will be c by a. Okay, now the question can be asked like this: they will provide you alpha value, okay, they will provide you sum of zeros, they will ask you to find beta value and product of zero value. Okay, that's nothing much to do. You know the sum of zeros as the net result, alpha value, so subtracting sum of zeros minus alpha will provide you beta. That will be substituted over here. Alpha we know, beta we found, multiplying we got product of zeros. So what we need to know is this value, that is alpha plus beta is minus b by a, alpha beta is c by a. If you know this pakka, remember this, whatever the question may be, they will be twisting you by giving product of zeros and they will ask you sum of zero. They will ask you, they will give you sum of zero and ask you to find beta value or alpha value, whatever it may be. If you clearly write this one, then 100% you can literally solve the entire problem that is being asked in the question, right? So see, so, okay, let's we see the second example. Example 2, right? Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. Okay, verify the relationship between zeros and coefficient. It's nothing but what? Sum of zeros, product of zeros. That's it. We have to verify the relation. If they ask you verify the relationship between zeros and the coefficient, merely you have to write sum of zeros and product of zeros only. Okay, first question is find the zeros. Again find the zeros for x square plus 7x plus 10 by splitting the middle term we can find the value of x. So what they have arrived is minus 2 and minus 5. general splitting the middle term for this equation. Okay, yes. Now sum of zeros as the formula suggests, it is minus b by a. So minus b by a. Okay, fine. So it will be minus 7 by 1. Okay, again sum of zeros, what we have to do, these two are the zeros, we need to add. So minus 2 plus minus 5 again give you minus 7. So by the formula sum of zeros is equal to minus b by a, it is verified that both the value, when we add, literally add two zeros, and if you arrive from the equation, both means the same. So it has been proved, right? What about the product of zeros, that is coming the next step? We know that product of 0 is c by a, right? Product of zeros is c by a. So c is 10, again 1. So product of 0 should be 10, right? Again minus 2 cross minus 5 is nothing but 10. So product of zeros is also perfect by the equation, or by the formula c by a to this equation x square plus 7x plus 10. Fine. So by this way you can find the value, or finding the zeros of the polynomial by doing the splitting the middle term and arriving the value also, no problem in this situation. Yeah, but what is the main thing? They are asking you to verify the relationship between the zeros and the coefficient. So by splitting the middle term, you will arrive the zeros as minus 2 and minus 5. And we have to put this because they are asked you to do verify the relationship. So no other go, you have to write sum of zeros and product of zeros again separately. Okay, fine. Then yes, example third one. But find the zeros of the polynomial x square minus 3. Right. Whenever you are reading these questions, just write the polynomial that has been given. Right. Verify the relationship between. Okay. Again the same thing. Find the zeros. Verify the relationship. So for this, the 0 is root 3 and minus root 3. Okay. The same thing, right? X square minus 3 is represented as x plus root 3 and x minus root 3. Okay. Now again adding these two, we get 0. Multiplying these two, we get minus 3. Okay. Wait. Adding, we arrive 0, and for multiplying we arrive minus 3. Okay, these are the sum of zeros and product of zeros for this question asked. That's it. Okay, what happens over here? Find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2. Right. Okay, they are asking you to find the quadratic polynomial, and they have given uh, what is the sum of the zeros and product of the zeros. Sum of 0 is minus 3 and product of 0 is 2. So that is alpha plus beta, and this is alpha beta. Alpha plus beta is minus b by a, alpha beta is c by a. Okay, now this is generally, we can just substitute over here x square minus sum of zeros, as I told you before, minus of minus 3x plus 2. So that is x square plus 3x plus 2. This is the quadratic polynomial to be arrived for this question. So they are given over here, and these are the checking methods that are being done. Again, they are rechecking whether the answer arrived is correct or not. That's it, not to bother much about that. The same thing they are talking for a number of times in this examples in this chapter, again and again, to find the zeros by using these values. That's it, nothing much to get complicated in this chapter, right? Okay, now this is one of the example given, formula has been given, right? What is this? It is nothing but this is for a cubic polynomial. Till now we saw for 2, right? power 2, x square plus x plus 3, whatever it may be. Now from now we are going to see x cube plus x square plus x plus a, whatever it may be. Okay, so now we step into cubic polynomial with the highest power will be 3. So there will be 3 zeros, that will be alpha, beta and gamma. Okay, now we are going to see for 3 zeros. So okay, again sum of zeros, alpha plus beta plus gamma is equal to same minus b by a. Now product of two zeros and summing up, there is a difference between these two. This is just sum of zeros, and product of zeros is also there, that is nothing but d by a, that is minus d by a. It is not c by a. Now c by a, for what we are using c by a is nothing but product of two zeros and summing up, that is alpha beta plus beta gamma plus gamma alpha, that is equal to r c by a. Why this is needed? Because in a plus b plus c, the whole yeah, square, what we will do here, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Again taking 2 common out, we get ab bc ca. So what will be the answer for ab bc ca? It's nothing but c by a. So for that purpose they are giving this one. When we square out, we need that value to be analyzed. So alpha beta plus beta alpha, I mean beta gamma plus gamma alpha will be c by a. So for that purpose this one is also introduced inside. So what is the first example? Verify that 3 minus 1 by 3 are the zeros of the cubic polynomial that is given, and then verify the relationship between the zeros and its coefficient. Okay, cubic polynomial, as I told, ax cube plus bx square plus cx plus d. Now they have given what is the values of the zeros and the cubic polynomial. So with respect to the ax cube plus bx square plus cx plus d, they are splitting the values to a b c d with respect to the given input polynomial. And see, the polynomial is 3x square, I mean 3x cube minus 5x square minus 11x minus 3, that is equal to p of x they have given. Here they are substituting a, I mean analyzing, assigning a to be 3, b to be minus 5, c to be minus 11 and d to be minus 3. Right, now again applying the formula. Before applying the formula, what we have to find, what is the value of p of 3, p of minus 1, p of minus 1 by 3, because to verify or to cross check with the result which we are obtaining. Okay, they are asking us to verify whether these are zeros. So we need to find, right, we need to substitute these 3 in x value, this minus 1 again in x value, this minus 1 by 3, yes, minus 1 by 3 again in x value, right? So if the answer yield 0, then individual thing which yield 0 will be the zeros, right? So they are substituting it for minus 1 by 3, and for 3 they are yielding 0 individually. So these 3 are zeros of the polynomial. Okay, the first condition given in the question, that is to be verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial is verified. Okay, but the question does not end here, right? The main content or the main thing that is to be analyzed in this question is coming now. What is that? Is verify the relationship between the zeros. Again, the relationship for 3 zeros, the formula is given here in the top of this textbook itself. So the 3 zeros are 3 minus 1 by 3, right? These are the 3 zeros. It let individually be alpha, beta, gamma. We need to verify. So Okay, adding up these three, what happens is 3 plus minus 1 plus minus 1 by 3, right? If we add, we arrive 5 by 3. So by the formula minus b by a, we need to cross check with this equation, right? Whether the value is same, okay, it has been verified. If it is not same, hence it is not same. That's it. We need to verify it is right or wrong, right? B value is minus 5, minus b means 5 by a value is 3. Yes, so these both are same value, right? So first condition is been verified that sum of zeros of the polynomial as well as the sum of zeros arrived by the equations which we substituted or they have been given, right? Yes, the given zeros are the zeros, and while we are doing the sum of zero step, we get the same value, right? So sum of zero step part is completed, right? Again the same thing. See, this is with respect to the formula it is given. We need to just cross check whether the thing which is given by the question is pukka or not, right? So the second one they are given has to be minus uh yes, alpha beta, the second equation, alpha beta plus beta alpha plus gamma alpha, right? Substituting, this is equal to c by a, right? C by a, that means the value should be minus 11 by 3. What we have to do, the alpha value we know that it is 3, beta value is minus 1, gamma value is minus 1 by 3, right? Yes, again merely we need to substitute again. We need to substitute and check whether the thing which we given is true or not. So alpha value is 3 and beta value is minus 1, so the net result will be minus 3 plus minus 1 into minus 1 by 3, it is 1 by 3 plus minus 1 by 3 into 3 will be minus 1. What will be the answer? Minus 4, right? Minus 4 plus 1 by 3 will be minus 11 by 3. Yes, I got minus 11 by 3, I got minus 11 by 3. Both the values are same. Hence verified with respect to the second relationship that is being given in the formula, right? Okay. What will be the third one? See, there is a chances of getting the third one to be verified too, as because the first two are verified. There's a chances, right? Okay. Let's we check it whether it is right or wrong. Okay. Alpha, beta, gamma. 3 cross minus 1 by 3 cross minus 1. What we arrive, 3 3 gets cancelled, the net result is 1. That is nothing but minus d by a. Minus d is nothing but 3 plus 3 by 1 by a, right? A is nothing but again 3, not 1. So the net result is 1 1 1. Again both are same. So we verified that the relationship between the zeros and coefficients are same. That's it to be done. Okay, this is a simple, one of the simple sum in the entire unit, this one. And confirm question, right? Mark this, it will be a confirm question even in your class test, school test, and even in the board exams. It's a confirm question that will be asked, okay, by the CBSE. They will ask this verify problem pakka. Okay, this is easiest problem in this polynomial lesson and compulsory problem 2, right? Again, see, find the zeros in this exercise. They have given find the zeros of the quadratic polynomial and verify the relationship, as because the same thing which we did over here. The same thing, we need to find the zeros of the polynomial. Yes, see, we need to find the zeros of the polynomial. We need to we need to verify the relationship. See, we will just do that splitting the middle term. We will arrive the zeros and sum of zeros, product of zeros. The same thing that is to be done for this all 6 problems, right? And what is the next one? Find a quadratic polynomial, each with the given numbers as the sum and the products of its zeros respectively. So the first question, do the splitting middle term. Oh, yes. Splitting the middle term for the first question. For the second question, as I told, that x square plus sum of zeros of x plus product of zeros. This sum of zeros, where it is 1.4 for first question and product of zeros will be -1. That's it, literally just substituting this. Okay, if you guys didn't arrive the answer, text me in the comment section. I'll work it this exercise 2.2 fully in another video and I'll post it, because it is not that much complicated thing, so I'm not wasting the time. If again and again, if we work out all the six and these six problems, I'm damn sure you guys will get bored, because the same process, the single step process, has been continued for all six questions or 12 questions, right? This has one same single step process, this has one same single step process, both are literally similar. So again and again working out the same thing which we saw last, uh, that example sites, literally everyone will get bored. It's the same steps to be worked out over here also, right? If you guys have any doubt, kindly text me in the comment section. I will post another video for exercise 2.2 alone, working all the problems that is being present. There's 12 problems again, each step by step. Okay, so if you guys have any doubt, if you didn't understand any topics over here, you kindly text me, right, in the comment section, and I will work it on in another video, and I'm sure I will post it shortly, right? Thank you guys. So if you have not subscribed my channel, kindly subscribe it for getting the more updated videos of mine, to study what is their concepts and everything, and get a good marks in your board exams and do it well. So thank you guys. We'll meet you in the next chapter of class 10th max. Thank you.